Namaste learners, I am going to talk about the Wheatstone meter bridge, potentiometer and heating effect of current. And start with the first topic, Wheatstone bridge. A scientist, Charles Wheatstone, a scientist whose name is Charles Wheatstone, arranged 4 resistors as like this. This one is the 4 resistor as like this, and a galvanometer is set in between this, okay, and one switch is here and one switch is another switch is here, and this one is the A, this one is the B, this one is the C, this one is the D. And suppose the current flows from this cell is capital I. This one is the capital I. And this is also I. When it is a small I, then a small I into I. And this one, in this circuit, this is the IG. And this becomes I from the KCL, I minus Ig, this one, and it becomes again I minus I, or this one is the plus Ig when switch is on, and this becomes I. This is the current distribution. Means the 4 resistors PQRS, the resistors is PQR, the resistor it is the P, and this is the resistor Q, this is the resistor R, and this is the resistor S. PQRS, PQR and S are 4 resistors, arranged in this way, and there is no current flowing, I is equal to 0. This is called balanced condition. This is the balanced Wheatstone bridge. Wheatstone bridge means the potential difference between VB and D is 0, means equal. Potential difference between VB and VD is 0 when E is open. This is the KG, means K1, and this is the K1, suppose that, and this is the K2. And this is the story of Wheatstone bridge, where VB equal to VD, then P by Q is equal to R by S. The ratio of 2 resistors P by Q is equal to R by S. This is the story. And now we want to prove these relations by the Kirchhoff's law. The first is switch is open, switch is closed, not open, switch is closed, and here is also closed. And one thing is, when you want to find the balance point, then first switch is on is here and other K2. First you on the switch K1 and then on K2. Okay, for the some precautions of the circuit. And first of all, I consider a loop. The loop is A. The loop is this. This loop is A. Okay, B, D, and it becomes A, means loop 1. And from the principle KVL, Kirchhoff's potential law, and according to this law, the summation of V is 0 in closed loop. Okay, and this one is I into P, between A and B, I into P, and between B and D, it is Ig into capital G, and this is between D and A, it is minus sign because we are going opposite to the current direction, then it is R, and this one equal to 0. Very simple. And if bridge is balanced, if bridge is balanced, it means Ig equal to 0. There is no current flowing through the galvanometer, and the equation becomes Ip is equal to I minus I into R. This is the equation number 1. Now, I considered second loop. This is the second loop. The name of second loop is B, C, D and B. This is the loop number 2. Okay, this is the loop number 2. And again using KVL, means the summation of V is equal to 0. Then the equation is, first of all, I am going along the direction of current, then it is I minus Ig into the resistance is Q. Current into resistance is potential difference, and this is going opposite direction of current, then it becomes a minus sign, and this is I minus I plus Ig, okay, into S, and along the across the galvanometer it is minus Ig I into capital G equal to what? 0. And for the balanced Wheatstone bridge, Ig equal to 0, it means this one is I1Q, okay, minus I into S, and this one is also 0 equal to 0, then IQ equal to I minus I into S, equation number 2. Dividing equation 1 and 2, we get IP by IQ is equal to I minus I into R upon I minus I into S. I and I cancel, this one is cancelled, therefore P by Q is equal to R by S proved with the help of a Kirchhoff's law. This is very simple. Okay, once again, if there are 4 resistors arranged like this, then the potential difference between VB and VD is 0, or the potential is equal at VB and VD. If the potential is equal at B and D, then there is no current flows across the galvanometer. One more method to prove this one. If VB equal to VD, it means VA minus VB is equal to VA minus VD. This is equal. If VB equal to VD, then we can write VA minus VB equal to VA minus VD, and VA minus VB equal to I into P, and this is equal to I minus I into R. This is equation number 1. Again, VB minus VC is equal to VB minus VC is equal to VD minus VC, and it's I minus, this is the I minus, and I consider if it is equal, then Ig equal to 0, then only I consider IQ is equal to I minus I, and here notice that Ig equal to 0, I consider Ig equal to 0, then I minus I into S, equation number 2, and dividing equation 1 and 2, you get P by Q equal to R by S. This is the another method. And method is same, just I consider Ig equal to 0 and VB equal to VD. One more concept here. If VB not equal to VD, suppose that VB not equal to VD, then what happens? Then current flows from VD, from D to B. If PS is greater than Q1, if PS is greater than Q1, okay. अगर VB और VD बराबर नहीं हो तो करंट फ्लो करेगा D से B की ओर, कब? जब PS क्या हो? बड़ा हो Q1 से. Here the topic is I interchange the galvanometer and cell. Galvanometer is in this position and cell is in this position. Here the cell is in between the circuit and galvanometer is the outside the circuit. Okay. Then it may be possible in case is also P by K equal to R by S. Just I proved in previous topic P by Q equal to R by S. Now we want to prove this one. Okay. Then suppose the current is I in this way. Current is I coming out from the cell, and here is the junction. Then suppose this is the I. Then current is I minus I, and here is a suppose that a current Ig, where I consider a balanced grid and it becomes 0, and that's why this is the I. Okay, and from this circuit this is also Ig, but Ig is considered at 0, and that's why this in this line this is I minus I and becomes here I. And now consider a loop. Which loop? Consider a loop in I like this loop. This loop we consider. Suppose that potential is or consider this loop. Means A, B, C, and this is the G. Consider loop. Consider loop. Loop. Which one? A, B, C, G, A. Consider a loop A, B, C, G, A, B, C, G, and A. And from this loop, we can write the equation from A to B means minus I into B, because I am going from A to B and current is coming from B to A. That's why I consider I minus IP. And from B to C, it is plus sign because I am going B to C and current is also from B to C. Then I minus I, and it is Q. It is Q. And this is the galvanometer. This is the galvanometer, and the current is 0. And if you want to consider, then minus Ig into G equal to 0. And it is Ig equal to 0 because it is balanced. Balanced Wheatstone-Bridge. If it is balanced, then Ig equal to 0. Then minus Ip is equal to minus Ip plus I minus I into Q equal to 0. That means Ip equal to I minus I into Q. Equation number 1. And also the consider loop, and also consider loop. Consider loop. Which loop? ADC GA. Consider loop ADCGA. Okay. Then the current is IR. The current is IR because it is positive. A to D, it is positive. Then ID. Okay. And this is the DC. In current DC. Suppose opposite direction. Then consider I minus into what? S. And this is 0. Then don't worry. And IR is equal to I minus I into S. Equation number 2. Easily you can find the value 1 is divided by 2. Then P by R is equal to Q by S. You may write P by Q is equal to R by S. Then this equation and this equation both are similar. This equation and this equation both are similar. Hence we can say that the cell and galvanometer can be interchanged and there is no effect on the equation. You can see in image there are 3 different ways or more ways to draw the circuit of Wheatstone-Bridge. The topic is meter bridge. Meter bridge is a device which measures the unknown resistance and ratio of unknown resistance and temperature, unknown temperature, okay, of the environment or any substance. And this device has a wire A and B, and AB is a wire. This is called AB bridge wire. This is called bridge wire. Okay, and it is made up of generally two materials, Constantine it is a alloy, and the copper is approximate 60% and nickel is 40%, and the resistivity of this material is 49 into 10 to the power minus 8 ohm meter. And the second material is actually manganese, and it is also an alloy and made up of copper 84% and 12% is manganese. 12% is manganese and 4% is nickel. And the resistivity of this material is 48 into 10 to the power minus 8 ohm meter. This is the wire, meter bridge wire, and this is the copper strip. To reduce the resistance of the wire, and this is a arm, 4 arm here generally, 1 arm in here, second arm, third arm, and 4 arm, and this is a connecting point. Here is galvanometer connected. Here is the galvanometer connected as like a Wheatstone bridge, because it is the principle of meter bridge is principle of, which is very important, meter bridge, and it is also called slide bridge. The principle of meter bridge is if there is no current flows across galvanometer, then P by Q equal to R by S. This is the basic principle of meter bridge. And according to this principle, if there is no current flows through this galvanometer, then the resistance is connected along this and this. And this is known resistance, this is unknown resistance S, and the point where balance point is J and the length of this is L, suppose, and then this is 100 minus L, because the length of AB is 100 centimeter. Total length of AB is 100 centimeter, 1 meter. And then moving the jockey, this is J for jockey, moving the jockey on the meter bridge wire to search the balance point. If it obtained, then there is no current flows through this, means it becomes balanced. Then first application of this meter bridge to find the unknown resistance S. The first use or application of this meter bridge wire is to find the unknown resistance. Unknown resistance. This is the first application of meter bridge. How it is obtained? Suppose move jockey on meter bridge wire to search of balance point. Suppose it is at J. मान लीजिए कि J पे है, then the length of AJ is L, then the length of JB is 100 minus L, and the resistance of AJ is suppose P, and the resistance of JB is Q, and R is the resistance per unit length. Then the resistance of AJ is LR, and the resistance of JB is and this one is equal to P, and the resistance of JB is equal to 100 minus L into R. This is equal to Q. Then if no current is flowing through the galvanometer, if no current flows या flowing in galvanometer, it means Ig equal to 0, then P by Q equal to R by S. By the principle P by Q equal to R by S, then formula becomes L by R, P by Q, L by LR, and this one is the 100 minus L into R is equal to R by S. This is R by S. Then formula becomes L by R is P and 100 minus L into R is Q. Then the formula becomes P by Q equal to R by S. This becomes equal to, by the formula P equal to Q by RS, P L by R and R cancel, then L by 100 minus L equal to R by S, then S is unknown resistance, then it becomes R into 100 minus L by L. This is the formula of unknown resistance. S is unknown resistance. This is the unknown resistance. And the application number 2 is to find ratio of unknown resistance. Ratio of two unknown resistances. This is the place of connecting unknown resistance. Then there are two resistance, consider R1 and R2. Okay. Then first of all connect R1 between the arms of unknown resistance. Okay. Move the jockey on meter bridge wire to search balance point. Let it is J at length L1. Okay. Then this is AJ equal to L1 and the resistance of this is suppose P, and P is equal to L1 R. As you know, R is the length resistance per unit length, and BJ is L2 means 100 minus L1. This is the 100 minus L1 and this is the Q, and this one is the 100 minus L1 into R. And the second process is now connect R2 in place of unknown resistance, and R1 is removed. Then we find the new balance point. The new balance point means Ij dash is L2. Then Bj dash or Jb dash, J dash B is equal to 100 minus L2. And the resistance in this condition is, suppose that P dash is equal to L2 into R, and this is another case, and this is the Q dash is equal to 100 minus L2 into R. And if balance point is found, then the value of R1 in this case, the first case, then what happens? Then P by Q is equal to R by S. Then P is L1 and Q is 100 minus L1, and this is the R1 into S. and sorry, R by R1. This one is the R by R1. R by R1. Then R1 is equal to 100 minus L1 by L1 into R. Similarly, R2 is equal to 100 minus L2 by L2 into R again. Okay, then dividing equation 1 and 2, yes, R1 by R2 is equal to 100 minus L1 by L1 by 100 minus L2, and arrange this one is L1 L2 is equal to L2 by L1 into 100 minus L1 by 100 minus L2. This equation is ratio of unknown resistance. You can also find the value of R series, means equivalent resistance in series combination, and also you can find the value of Rp or any equivalent resistance which is not found by the formula. And if this is the two ends, a resistance is this manner, anyway this manner, anyhow resistance is connected, then considered as a unknown resistance. And what is the value of this resistance, I don't know, but first of all you search the balance point at J and find the value of length L, and the second length is 100 minus L. Then after the finding the balance point, you use the P by Q equal to R by S, and P is just like L, and this one is the 100 minus L, and R is the known resistance, and S means what? R equivalent. Then R equivalent is equal to R by L, yani 100 minus L by L. Either it is series, either it is parallel, it doesn't matter. जो भी हो, जैसा भी रेसिस्टर्स हो, उसका दो एंड हो, नहीं मालूम चल रहा है कि फॉर्मूला से क्या होगा इसका सीरीज पैरेलल, तो बस क्या करना है, दोनों फोर्थ आर में क्या करना है, इसको अटैच कर देना है, और जो व्हीटस्टोन ब्रिज का प्रिंसिपल है P by Q equal to R by S, उससे आप R इक्विवेलेंट निकाल सकते हो. एक और यूज, if once find the value of R of any y, okay, suppose that at this place you consider a y of length L. L is the length of y of unknown resistance. Then first you find the value of R by the meter bridge. Find value by meter bridge, and length is measured by the scale, and find the cross section area with the help of a screw gauge. Diameter is measured, then area is pi r square, or it is equal to PD square by 4. Once you find the value of PD square, then as you know the formula of resistance is equal to rho L by A, then rho equal to RA by L. This is main point. R is measured with the help of a meter bridge, A is measured with the help of a screw gauge, and L is measured with the help of a scale. Simple way. R is known, A is known, L is known, then you find the value of resistivity of material. Resistivity of material means with the help of meter bridge you can also find the series, parallel, R equivalent and the resistivity of the material. The third application is to find unknown temperature, capital T. And for this, I have taken a platinum resistance, which is very sensitive, to temperature. Suppose RT is the resistance of platinum wire at T temperature, and R0 is resistance of platinum at 0 degree centigrade. Okay, and by formula, as you know, RT is equal to R0 1 plus alpha into delta T or T. This is the change in temperature, and alpha is temperature coefficient of resistance. Temperature coefficient of resistance means RT is equal to R0 plus R0 alpha into T, and RT minus R0 is equal to R0 alpha T, then T equal to RT minus R0 by R0 into alpha. And RT is find with the help of a meter bridge. This is a platinum resistance, and first of all this platinum resistance is put inside a liquid or medium which has a known temperature T, and the resistance at that temperature can be found with the help of a Wheatstonebridge principle. That means P by Q equal to R by S. P by Q means P is L and this one is the 100 minus L, and if it is this is a known resistance R and unknown resistance is R0. Okay, then R0 is the resistance at 0 degree centigrade. It means R0 is 100 minus L by L into R. Simply you can find it with the help of meter bridge, and again using P by Q equal to R by S. This platinum resistance is put in a medium, then the length is, suppose second length is 100 minus L1 is equal to R by, this one is the RT, and RT is equal to 100 minus L1 by L1 into R. Just you find the value of RT from here and R0 from here, and you can put this value in this equation, then you can easily find the unknown temperature. This is the third applications of meter bridge. Then with the help of meter bridge we can find the unknown resistance first, the ratio of unknown resistance, the value of series combination, the value of parallel combination, or the R equivalent, either series or parallel or either mixed connection, and the unknown temperature. And one more thing is to find the resistivity of a wire. If a wire whose length is measured with the help of a scale, and resistance is found or with the help of a meter bridge, and cross section area with the help of a screw gauge, and these all are putting the formula in formula rho equal to R and A by L, and this formula gives the value of resistivity of the given wire. Next topic is potentiometer. As like a meter bridge, potentiometer is also device which has 10 watts or 4 watts. Generally 4 wires or 10 wires. Each has a length 1 meter and made up of a constantine and manganese. Okay, constantine and manganese is a LOI, which is made up of a copper, nickel, and manganese is copper, nickel, and manganese. Okay, just discussed in previous topic. Here is the principle of potentiometer. On which principle it works? Principle of potentiometer. Potentiometer. It is also very important. And as you know, V equal to IR. Then V equal to I rho L by A. Then V is equal to I rho by A, and this one is L. Then V directly proportional to L if I rho and A is constant. If A rho and A is constant, then potential drop is directly proportional to length. Means potential difference across a wire is directly proportional to length, and it has a 10 wires or 4 wires. Generally I draw here 4 wires potentiometer. Okay, this is the 4 wire potentiometer. This point is known as A, this point is known as B. This is the point A and this is the point B. And in between there are 4 wires, 1, 2, 3 and 4. Each has a length 1 meter, and this wire is clamped with a copper wire, copper plate, thick plate. Why it is thick? Because the resistance of thick wire, thick plate is negligible. This one is the thick copper plate. Thick copper plate. Okay. This is the potentiometer and it is mounted on a wooden block. This is the wooden block. And as shown in figure, images. This is the potentiometer and this is A, this is there are 2 units. And some potentiometer has the 10 wires, 1, 2, 3, 4 and more. And this potentiometer has 2 bed cells. One is the auxiliary cells and other is the main cells. And this is the one rheostat here, and this is the connection, and here is the cell connected, battery connected here in this way, and this is the another cell. And you may use the key, okay, and you may use the ammeter or the measurement of current, and this is the rheostat to just arrange. And here you may use a cell and a galvanometer, and one is the jockey to search the balance point. Balance point means the potential at A is equal to potential at J, and there is no current flows through the galvanometer, because first of all you set the I constant, means a steady current must be flows through the potentiometer wire. Rho is the resistivity, means resistivity material is same, always keeping same, and A is the cross section area, and that's why jockey is not rubbed on the wire, just it is tapped. Okay, just means tapped means search the zero potential, then this like a searching is provided, or if you just rub on the wire, then cross section area is disturbed, and that's why your reading is not very good, and that's why you tap on the wire, jockey tap on the wire to search the potential difference 0. Means the potential A and G is equal, means the potential A and G equal to the potential between the cell. Then what is the use of this potentiometer? The use of potentiometer to find the first use, to find EMF of unknown cell, EMF of unknown cell, This is same arrangement. This is the unknown potential E. Okay. And we want to find the unknown potential E. This unknown potential. Then first of all, I connect a standard cell of 1.018 volt of potential difference between the points A and J. Between the point A and J. A और J के बीच में सबसे पहले एक स्टैंडर्ड सेल लगाएंगे जिसका वैल्यू होगा 1.018 एंड मूव जॉकी एक प्रकार का एक कनेक्टर होता है, मेटल होता है, जिससे इसे पकड़ करके उसको हम टैप करते हैं पोटेंशियोमीटर वायर पे, और कुछ नहीं है, जॉकी बस उसको कनेक्ट करने के लिए। तो मूव जॉकी ऑन पोटेंशियोमीटर वायर टू सर्च बैलेंस पॉइंट। बैलेंस पॉइंट मीन्स there is no current flows through the galvanometer. Okay, then it is found at 203.6 centimeter because it is fixed. Why? The potential difference is 1.018 volt. Okay, and that's why it is fixed. Then you can find the value of potential gradient. This is the value of potential gradient. And this is equal to 1.018 upon 203.6, and this is the volt, or this one is the centimeter. 5 into 10 to the power minus 3 volt per centimeter. This becomes 5 into 10 to the power minus 3 volt per centimeter. Now a standard cell is replaced. By unknown EMF, replaced by a cell whose EMF is unknown. पहले क्या किए, इस पोटेंशियोमीटर में एक स्टैंडर्ड सेल लिए, उसको लगा दिए। स्टैंडर्ड सेल लगाए तो हम फाइंड किए कि कितना सेंटीमीटर पे ये बैलेंस पॉइंट आ रहा है। 203 कहाँ आएगा, 100 तो यहाँ हो गया, फिर ये 200 हो गया, तो इसका मतलब 203 लगभग यहाँ आएगा, इस पॉइंट पे आएगा J, इस पॉइंट पे आएगा। ठीक है, तो ये जो गैल्वेनोमीटर का J हम जो यहाँ बनाए हैं, ये J एक्चुअल में ये J जो है हमको दिखाना है कहाँ, यहाँ दिखाना, ये J होगा, है ना, ये J। अब क्या कर रहे हैं कि वो स्टैंडर्ड सेल को रिप्लेस कर रहे हैं, किससे, जिसका ईएमएफ निकालना है, जो अननोन है। ये तो पहले हम किसका लिए थे, 1.018 वोल्ट का लिए थे शुरू में, जिसका हम 1.018 लिए थे, उसका जो लेंथ लिए हैं 203.6 सेंटीमीटर पे बैलेंस पॉइंट है। दूसरा केस में क्या करेंगे कि ईएमएफ जो अननोन था उसको लगा देंगे। अब लगा दिए तो कुछ ना कुछ लेंथ उसका आएगा, उसको लेंथ मान लीजिए कि लेट L be the length of balance point. L be the length of potentiometer wire at which balance point is found. है ना, वैसा लेंथ है जहां पे बैलेंस पॉइंट हमको मिल गया है, और उसका लेंथ क्या लिए हैं, L। तो हमारा ईएमएफ कितना होगा, तो ईएमएफ के मतलब क्या है कि अगर dV/dL इक्वल टू हमारा इतना आ रहा है तो टोटल में कितना आएगा, तो हम सीधा कर देंगे कि अननोन ईएमएफ इक्वल टू पर यूनिट लेंथ का ये आ रहा है, तो दिए गए लेंथ का कितना आएगा, यही फॉर्मूला जो है आपको काम आ जाएगा। This is the value of unknown EMF. Value of unknown EMF. Once again, I repeat it. First of all, you arrange the circuit of potentiometer, and first you connect the standard cell here and find the value of dV by dl, and dl is at 203.6 centimeter because it is 1.018. Then you find the potential gradient, means potential per unit length. Now a standard cell is replaced by the cell of whose EMF is unknown. Then just we find the value at L where balance point is found. Then the EMF of cell is equal to dV by dl into L. This is the value of unknown EMF. Okay, the second use of potentiometer is to compare EMF of two cells, and two cells is here. I have connected. The positive end of cell is here, and another cell is also positive terminal is in case, and the second point is here as like this, and from this connection, this is the 1 and this one is the 2, this one is the 3. And this is the galvanometer and this is the jockey. As you want, where it is found, suppose that this is the J. And now the point is here, an auxiliary battery and a rheostat is connected just like this rheostat. This is the rheostat. Rheostat means variable resistance is connected here. And this is the negative and this is the positive point. Positive point is also connected to the A. This one is the A. This is the arrangement of the compare of two EMF of two cells. And this one is the point 1. This is point 2, point 3. First of all, point 3 is connected with point 1 and move the jockey on potentiometer wire to search balance point. Let it is found at L1. L1 means just from starting from A, and this is 100 centimeter. Then something is here 100 plus few centimeter. Then this one is the L1. Then the potential at A is equal to what? Potential at J means the potential at AJ is equal to potential between this one is the E1, this one is the E2. Okay, then let I be the current, I be the current in potentiometer wire, I, and R is resistance per unit length. Resistance per unit length of potentiometer wire. Okay. Then the potential difference between VA minus VG is equal to total length is L1. This is the L1. Resistance is R and current is I. This one is, and this is equal to E1. This is equal to what? E1. Then E1 is equal to L1 R into I. Equation number 1. Similar way. And now E1 is replaced by E2. Or now point 3 is connected to point 2 and move jockey on potentiometer wire to search balance point. balance point, to search balance point. Let it is found at L2. Then similarly E2 is equal to L2R into I, equation number 2. Dividing the equation 1 and 2, we get, dividing equation 1 by 2, we get E1 by E2 is equal to L1 Ri by L2 Ri. This one should be cancelled out, then E1 by E2 is equal to L1 by L2. Third use of potentiometer to find internal resistance of cell. Internal resistance of cell. This is similar way. A potentiometer is a, suppose this one is the length, second, third and fourth, and this is connected as like this, and this is the copper strip for the reducing resistance, because the thick resistance has very zero resistance. This one, this is the point B, and from point B, this is what? Nothing, and here is the rheostat, means variable resistance. This is the negative point and this is the positive. You may attach the jockey plus and minus, and this is the point A, and from here you attach as EMF, and this is the external resistance R. You may capital G. Here also you use the resistance for the protection of galvanometer, and it is nothing another purpose, and one jockey. This is the jockey to search the balance point. And this all arrangement is, mounted on a wooden plank as shown in images display on your board. This is the wooden block in plank, and similar way first, and here one key is also placed. Here is a 100 centimeter, here is a 200 centimeter, here is 200 centimeter, here is the 300 centimeter, here is the 400 centimeter. And if you just count from here 100, 200, 300, and it is the 400. First of all, key K is open. It is not connected. Then the potential difference between A and J is equal at point J, and length is L. Suppose, and if you want to consider L1, then you consider L1. This is the L1, and at this stage the EMF is equal to the L1 internal resistance R and current is I, equation number 1. Now key is closed, K is closed. It means when K is open, then there is no current drawn with the cell, but when K is closed, then some current withdrawn with the cell, and this is the terminal potential. Actually this becomes terminal potential because cell provide a current in the resistance capital R. That's why V is equal to, the length is L2, resistance is R, and current is I. This current is the current in potentiometer Y. and which is a steady current, and R is the resistance per unit length. Dividing the equation 1 and 2, we get EMF by V is equal to L1 by L2. तो आप कहेंगे कि सर इसमें कौन बड़ा ताज्जुब की बात है, ये तो हम पहले भी किए। हाँ, पहले भी किए। As we know that a small r is equal to E by V minus 1 into capital R. As you know, R is the external resistance of what? External resistance of cell. Then E by V is L1 by L2, then internal resistance is here. If once L1 and L2 is found, L1 and L2, then you can find the value of internal resistance. You consider here is for the differentiate two resistances. And the next topic is heating effect of current. When current flows through the resistance, then resistance heats up, and this effect is known as heating effect. The application of heating effect is heater, geyser, iron, blower. These all are the applications or electric gadgets on the basis of heating effect, and every electric or electronic gadgets heats up due to this effect. And generally heating effect means heat is produced. Simply heat is produced or absorbed, maybe produced or absorbed. Okay, generally it is produced by the flowing of current in a circuit or electric or electronic appliances, as like a heater, geyser, iron, blower, etc. This type of instrument based on the heating effect. One or two more purpose is just like MCB is also, MCB means miniature circuit breaker. Fuse is also used of heating effect. Even a filament bulb is also heating effect. Filament bulb is also application of heating effect. Toaster, and actually work done means what? Charge into potential difference means QB. Generally it is written as QB. And heat is a energy. It is a energy. And Joule found that Joule's heating effect. This is also known as Joule's heating effect. He found that the heat produced in the wire or circuit or appliances is directly proportional to a square of I and directly proportional to resistance and directly proportional to time up to which or time duration up to which the circuit is working or it is in used. And by this formula he calculated the value of heat is as a H equal to I square RT. Here proportionality of constant is 1, and as you know why it is 1, then H equal to I square RT. The simple formula is H equal to I square RT, where I is current and R is the resistance. I is current flowing in the circuit, R is the resistance of circuit or electronic appliances resistance, and T the time duration. It is very important thing, time duration. Okay, then the formula is H equal to I square RT, and E is electrical energy, and it is measured in kilowatt hour. Actually it is measured in watt hour, measured in watt hour or WH, watt hour. Actually power is equal to energy, electric energy consumed or produced. The rate of energy consumed or energy produced by a electronic appliances is known as the power, and energy is electric energy equal to power into time. Electric energy equal to power into time. Energy equal to power into time, and that's why the unit becomes watt hour. And generally commercial unit is 1 kilowatt hour. This is the commercial unit. 1 kilowatt hour is equal to 1000 into joule per second into 3600 second, and it becomes 3.6 10 to the power 6 joule. 1 kilowatt hour is equal to this 3.6 into 10 to the power 6 joule, and this is equal to 1 unit. Okay, and you can find the value of unit and cost in which is used in your household. You make a table, and this is the serial number 1 2 3 and so on. You select the electronic gadgets, okay, and watt, power, and this is the quantity and total in watt hour. And you can, just like electronic gadgets, bulb, this is the bulb. Watt is suppose that 20 watt, quantity approx 10. And one thing is also time duration. In how time duration, how many minutes or hours are just like glowing, then it is 10, and you multiply these all things, then it becomes 2000 watt hour in a day. 2000 watt hour in a day. Same like, just like a fan, it is 80 watt. Suppose that it is 1 or 2, and this one is also 10 to 12 hours. Then we just multiply, and for the simplicity I want to write the 10, okay, then 1600, it becomes 1500, then this is become 3600 watt hour per day. You are consuming, means total energy you are consuming is 3600 watt hour in a day. It becomes 3.6 kilowatt hour in a day, suppose that. Then in a month you multiply this from the 30, and you can find the total cost. Then you multiply this with the 5 rupees or 6 rupees per unit, then you 5 into 3.6 into 30, this is your total cost of consuming electric energy. You can also use the formula power is H by T, then H equal to I square R into T by T, T cancel, then power it becomes P equal to I square. Okay, and you can convert these all in V square by R also, and P equal to VI as discussed in previous